in the context of AI, we saw how reasoning plays a very important role. So when you say reasoning, the idea is how you can infer new knowledge from existing piece of knowledge. That's the core idea of how reasoning plays a critical part of intelligence in human beings. So when you talk about reasoning in AI, we talk basically about three kinds of reasoning. The first one, which is basically what is known as a deductive logic or deductive reasoning. Second one is what is known as inductive reasoning. Third one, which is also quite useful in areas like diagnosis, it's called adaptive reasoning. Let's look at each of the reasoning scenarios and see where they're applicable and how humans use them in normal circumstances and how AI systems are built to use any of this. The most fundamental approach in any human endeavor of intelligence is how, given an existing set of laws governing nature or governing a particular phenomenon, how you are able to extrapolate that to another instance and see how that law is applicable for that instance. So basically, in one sense, we're talking about a very generic rule being present there governing the behavior and how you're using that to explain a specific instance of that behavior. So, for example, we can say that we observe any bird typically has a capability to fly, right? And then you find out that the crow which is sitting on your balcony is also a bird. So, given this universal law that all birds fly, you can infer a new piece of knowledge that the crow flies. So, this is a new piece of knowledge which has come from two independent pieces of knowledge. One is which says that all birds fly, and it says that the crow is a bird. So what happens is you have existing pieces of knowledge which are generic laws, and using that you created new piece of knowledge. So such kinds of reasoning where you're going from general rules to particular instance applications is known as deductive reasoning. And this is something which is quite often used in context of AI systems, and the underlying principle behind all of the deductive reasoning is some notion of a logic system which governs the relationship between the different rules and how new facts can be derived from existing set of facts. For example, in this case, we have two rules here where we say all birds fly and we say crow is a bird, and then we infer a new rule called crow flies, or a new fact. So this kind of a rule in classical propositional logic or first order logic is known as modus ponens. So if you see technically, if you want to write it, it says for all x, if something is a bird, it will imply that the bird will fly. Then you say that crow is a bird. So now you have one law which is saying all birds fly. Then you have one instance saying that crow is a bird. So now based on this, by using the modus ponens application, you say that fly of crow. So this is a new fact you derive by applying the rule on existing piece of facts which are universal laws. So that is what deductive reasoning always uses, some form of logic. The most simplest form of logic which is used today in electronic Boolean circuits is what is known as propositional logic, which talks about simple symbols and conjunctions or rejunctions of these symbols to give new expressions. Whereas extension of that, which is very useful in our common day-to-day life, where we talk about universe of things, which is known as first order logic, where we have expressions like this, where for all things some properties to be satisfied. So first order logic and propositional logic together form the basis of deductive reasoning of any AI system. This, while is good enough for capturing several conventional symbolic reasoning representations for deductive reasoning in AI systems, several times you may need to extend this notion to concepts like higher order logics and other common sense reasoning systems based on logic variants known as non-modern technologies, which is basically saying that I may not follow exactly what the first order logic would dictate me, but I would need to make exceptions. So that's where we are, in order for us actually to reflect to the earlier requirement of artificial general intelligence, we actually see that artificial general intelligence need more and more common sense behavior to be captured, and that's where first order logic may not be enough, but we see newer extensions called non-modern logics, which capture things like if birds fly, there can be exceptions like ostrich. Ostrich is an exception, though it's a bird, it cannot fly. So they need to be captured in scenarios which are more common sense, which may not be applicable by universal logical deductive reasoning principles like first order logic. So if you see deductive reasoning as at the core of AI systems, and this is as old as Aristotle, who invented this whole notion of logic and used it to derive newer and newer systems based on axioms and newer theorems and newer rules formation. Same thing we continue, and if you look at Euclidean geometry, which is a classical example of an AI system built on classical logic. So today deductive reasoning is one of the foundation of what we say as at the root of all the principles behind which any expert system or any kind of a knowledge-based system is made up of, and that's basically derives itself from the underlying principles of foundational logic. Coming to going beyond deductive, the opposite of deductive is what is known as inductive reasoning. Inductive reasoning is primarily focused on the notion of when you have a lot of pieces of particular form of instances of knowledge, can you create a generic rule or a general rule explaining the phenomenon? For example, if you see hundreds or thousands of birds flying, that this bird flies, bird 2, bird 3, bird 4, 100,000, bird million flying. Then you can say that here is a generic rule where I can say that if anything is a bird, it will fly. So this is a knowledge extracted from several low-level instances or particular instances being observed, and we are using this to generate a generic rule which is able to abstract a phenomena for that class of beings. So this is where machine learning plays an important role in form of being able to derive generic knowledge from lot of ground level knowledge. So machine learning is a classic form of inductive logic or inductive reasoning, where given a lot of ground instances of raw data, you're trying to infer general knowledge or general applicable rules from the low level data. So machine learning, you can say, is most often used as a form of inductive reasoning from several pieces of individual, particular, granular instances of information, and we're generalizing that to create specific rules which are abstracted enough to capture general behavior. The last of this is what is known as abductive reasoning. Abductive reasoning is a general third category of reasoning where it's not about going from particular to general or general to particular, but it is of a specific category of problems which are of the form cause effect. If there are several causes for a particular effect, then diagnosing which is the most likely cause for that effect is called abductive reasoning. Abductive reasoning plays a very important role in areas like healthcare, where you observe symptoms of the effect could be due to many other causes. So identifying the most likely cause given the effect becomes abductive reasoning. So abductive reasoning is a useful third category of reasoning useful in AI. Any AI system is either doing this or this or this or a combination of all the three.